Welcome back, everybody, to another version of Pure Awesomeness in Chemistry. So, ions with transition metals. Transition metals, first of all, let's define what transition metals are. So far, we have talked about this section of the periodic table as nonmetals. We've talked about everything else as a metal, right? We have this little bridge right here. These are called metalloids, kind of like in between metals and nonmetals. These over here are certainly metals. And these in here in the middle section where it's all blue right here, like this light blue, really nice color, those are also all metals, but they have a specific name. All of these middle section metals are called transition metals. So transition metals right here. Basically, it's just we're transitioning from these hardcore metals over here that are really reactive to some less reactive metals and nonmetals over here. But anyway, they are called transition metals. And there is a specific way that we use them in ions. And again, just like the polyatomic ions, you've already been exposed to these because on your lab you had Cu2+, you had CO2+, you had Fe3+, and you had Ag1+. So these are all transition metals right here that you were already exposed to. There's just one thing that we need to add to that. So when you're writing a transition metal formula, you have to use what are called Roman numerals. So you may have seen Roman numerals before. I'm certain most of you have. Roman numerals are just like, for like 2, it's like 2 I's put together, like 2, like that. That's 2. 1 is just like 1 I, capital I, like that. 3 doesn't get much more complicated, is 3 I's, like that, just all put together. 4 is an I and then a V. And then that is as high as we will ever need to get in this class. But 1, 2, 3, 4, those are Roman numerals if you hadn't seen Roman numerals before. So you have to use Roman numerals when you use these transition metals. And what I mean by that, so say you are given, like an example we had yesterday, you had CO 2+, so you had CO, cobalt, 2+, 2+, and then you had chlorine, which is 1-. So you had Cl, 1-, like this. So you should know how to do this. Ions, you crisscross, right? So you take this and you put it down here, and you take this and you put it down here, and so you end up with CO, Cl2, right? Because you move those, you crisscross those. We should be good at that by now. So that would be cobalt chloride. Pretty straightforward. But if we were to write that out, like actually type it and write it out, it would look a little bit different. So what you have to do with transition metals, so we were writing that out, we put cobalt, that's the same, and then we would normally put just chloride, right? Cobalt chloride, everything looks good. But transition metals are unique. They can have multiple charges. So you know how Cl is always 1-? Beryllium is always 2+. I had you write all those down on your periodic table. The reason we skipped here is because they can be 1+, 2+, 3+, and sometimes 4+. Like cobalt right here. Cobalt can have a charge anywhere from 1+ to 2+ to 3+ to 4+, depending on what it's bonding with. Now, in this situation, I gave it to you at the very beginning of the problem. I said we're dealing with cobalt 2+, and that's why it matches up so well with chlorine. So what you do, right after the transition metal name, in parentheses, you put the Roman numeral that represents the original charge of that transition metal. So we had cobalt, our original charge was cobalt, CO, cobalt 2+, right? Our original charge was cobalt 2+. So that means we would put cobalt 2. This 2 right here represents this 2+. So you put cobalt 2 chloride. And that's how you get your answer. Now, one thing that can be a little bit more confusing, which I'm sure you're just so excited about, is say I just gave you this right here. You were just given the formula. How would you know it's cobalt 2+? Well, all you do is you find out the charge of this back end element, this nonmetal. So you have Cl2. Cl2, its normal charge is 1 minus, yes? Okay, but we have 2 of them. So that means we have 2 1 minus charges. 1 plus 1 is 2, so that's how we would know to put the 2 right there, because this charge would have to equal this charge. So you'd have cobalt 2 chloride. Now, let us do another practice one really quick here. Delete cobalt 2 chloride. The next one we'll do iron chloride. So say I gave you something. Well, we'll do it the different way, the easier way, fast. So, well, we'll go with Fe, that is iron, FeCl3. Cl3. Okay, so the typical name for FeCl3 will be iron chloride, right? But you find out, you're like, oh no, iron is right here. It's a transition metal. That means I got to add a Roman numeral. That's what Mr. Wilson said. So that's what I got to do. So I have to add a Roman numeral because it's in the middle. So we have iron chloride. How do I figure out what Roman numeral should go in here? Well, I look at my second element, my nonmetal here, and find out the charge that it has, or the charge that it would have if it were by itself. So chlorine, I know it has 1 minus because it's in this column. So I know it has 1 minus. But how many chlorines do we have? We have 3 chlorines. So that would be 3 1 minus charges put together. So that means overall this would have a charge of 3 minus, meaning if this doesn't have a charge at all, then our iron must have a charge of what? If this has a charge of 3 minus, what does this need to have a charge of? 3 plus to cancel out those 3 minuses, which means I'd go back here, edit my name, and it would be iron 1, 2, 3 chloride. This 3 comes from the fact that iron would have to have a 3 plus charge to cancel out these 3 chlorines. Now, say I just gave you iron 3 chloride right there. How would you figure out what to do? Well, this right here tells you the charge of the iron. That's what this does. Maybe that's probably an important note that you should write down. The Roman numeral is the charge of the metal. And it's always positive. Always. It's never going to be negative. So that means if you have a 3 right here, that means iron is 3 plus. So you would know by looking at that it's Fe 3 plus, right? Fe 3 plus, just like that. Whoops, not just like that. That's a terrible plus sign. That's where we get that. This is the charge of the metal, which the metal is iron, and it's 3 plus. Then we have chloride. What's the charge of chlorine? This is just the same thing you've always done. Cl 1 minus. So how do we get the formula? We crisscross just like we always have. Take the 3, put it down here, take the 1, put it down here. So we end up with Fe 1, I'm not going to write the 1, and then Cl3. Everybody see how we got that? This right here is telling us the charge of the metal. And then we can just solve from there by writing it just like we do a normal ion. I'm going to do one more example if you need another example. One more example, and then I got to go to the tardy table because that's it's just awesome is what that is. So we'll do one with a polyatomic ion. So I'm going to start off with the name this time. I'm going to give you iron 1 nitrate. Okay. Step 1, tell me the charge of the iron. Tell me the charge of the iron. Okay, you should know this right here represents the charge of the iron. So the charge of the iron is 1 or 1 plus. So Fe 1 plus. 1 plus. Okay, now nitrate. Remember, that's a polyatomic ion, so we got to go back to our list of polyatomic ions that you wrote down. And you'll see that nitrate, remember you write it all down. It's NO3 and it's just 1 minus. So 1 minus, just like that. Then, how do we do the rest? We just crisscross. So we take this 1, we put it down here. We take this 1, we put it down here. Because they're both 1s, they cancel out, so we don't have to write out the actual ones unless you want. So it would be FE and then NO3. You could put parentheses around this if you want, because we talked about parentheses a lot, just to show that that's all together. So you have iron nitrate, and this 1 is what told you the charge of this iron would be 1 plus. That's what transition metals do. So those are some examples of transition metals. There were some examples of those that we did on the lab and on the practice with the polyatomic ions, so you are going to want to go back and take a look at that, and you're going to want to correct the formulas you wrote if you need to. I don't know that you will need to, but if you need to include these Roman numerals, because that is very important. So that is how we use these transition metals here in the center of our periodic table, and the reason, again, is because they can have multiple charges, like iron could be 1, 2, or 3, so we have to signify what it was, and someone's at my door, so I'm out. Peace.